Assalamualaikum. Today our group will be presenting about acid-base titration of vinegar. This experiment focuses on determining the concentration of acetic acid in vinegar using a neutralization reaction. So this is our group's members. Alright, for the introduction, acid-base titration is an analytically method used to determine the concentration of an unknown acid or base through a neutralization reaction. In this experiment, we select vinegar as our sample because it contains acetic acid, which affects its taste, quality, and safety. By titrating vinegar with a standard sodium hydroxide solution and observing the color change of an indicator at the endpoint, we can accurately determine the concentration of acetic acid. This method is important for quality control and food standard compliance.
The objectives of this experiment are: first, to measure the percentage of acetic acid in vinegar. Second, to ensure that the vinegar meets food quality standard. And lastly, to maintain consistent flavor and acidity. This objective help ensure that the vinegar is safe and suitable for consumption. For next slide is apparatus and substance used. For this experiment, we use several apparatus and chemicals. The substance used were vinegar, sodium hydroxide, and phenolphthalein as the indicator. The apparatus included a burette, pipette, conical flask, and a measuring cylinder. Each of these tools plays an important role in ensuring accurate measurement during the titration process.
The principle of this titration is based on a neutralization occurs at the endpoint. Phenolphthalein is used as the indicator, which changes color from colorless to pale pink at the endpoint. The chemical equation for this reaction is CH3COOH plus NaOH. Now let me explain the procedure. First, as much as 25.0 ml of vinegar is used and placed into a conical flask. Next, a few drops of phenolphthalein are added. Then, the burette is filled with sodium hydroxide solution. The vinegar is titrated with sodium hydroxide until a permanent pale pink color appears. Finally, the volume of sodium hydroxide used is recorded. This color changes indicated that the reaction has reached the endpoint. The indicator used in this experiment is phenolphthalein. In an acidic solution, it appears colorless. In a slightly alkaline solution, it turns pale pink. The endpoint is reached when a faint pink color persists, indicating that the acetic acid has been fully neutralized by the sodium hydroxide.
For this slide, I will explain how the concentration of acetic acid in vinegar is calculated. First, we use the titration formula, which is M1V1 equals M2V2. Here, M1 and V1 represent the acid, while M2 and V2 represent the base. In this experiment, the volume of vinegar used is 25 milliliters. The concentration of sodium hydroxide is 0.10 molar, and the volume of NaOH used during the titration is 20 milliliters. Next, we substitute the values into the formula. M of acetic acid times 25 equal 0.10 times 20. After calculating, the concentration of acetic acid is 0.080 molar. In conclusion, the concentration of acetic acid in the vinegar sample is 0.080 molar. This experiment has several real-life applications. In laboratory analysis, it helps determine the concentration of acetic acid accurately. In the food industry, it is used for quality control to ensure consistent flavor and product quality. In education, it helps students understand acid-base reactions and titration techniques. Lastly, it ensures that vinegar meets food safety and regulatory standards.
And for the source of error, first, overshooting the endpoint. Second, inaccurate measurement of substance. Third, improper indicator use. And lastly, uncalibrated apparatus. Acid-base titration of vinegar is a simple yet effective analytical method used to determine the concentration of acetic acid accurately. By reacting the acetic acid in vinegar with a standard sodium hydroxide solution and using an appropriate indicator such as phenolphthalein, the endpoint of neutralization can be clearly identified. This technique is widely applied in laboratories and the food industry to ensure vinegar meets quality and safety standards. Overall, acid-base titration demonstrates the practical importance of analytical chemistry in everyday products and quality control processes.